Okay, so hello everyone. In this video, we will cover error detection and correction. So, in this video, we will discuss error and types of error, and then detection method. In detection method, we will discuss single parity and CRC, cyclic redundancy check, and then a very important point, Hamming distance. We will cover Hamming distance. Okay, so the topic is error detection and correction. So, first of all, let's talk about what is an error. Simple meaning of error is the data which sender sends if receiver does not receive the same data. It means there is an kind of error. Okay, let me give you an example. If sender sends data 101 and on the way the data changes or whatever the reason, the receiver receive the data 100, there is an error in the data. Okay, so here the first point is that how will we know that error has come? Let's say sender and receiver are very far away. Sender is in India and receiver is in USA. Then how will receiver know that some problem has occurred on the way? Okay, so for that we use the error detection method. Okay, error detection method means at least we know that there is some kind of error in the data. Okay, because if I don't know that there is some kind of error in the data, then receiver will simply accept this data. Okay, but if you look carefully, what had the sender sent? 101 in binary. Okay, if we convert this into decimal values, it becomes 5. Okay, and here we talk about 100, it becomes 4. So data changes completely. Okay, so if we talk this way, that at least I know that there is some error, then we can use error detection method. Then comes error correction. Okay, error correction is an advanced step of error detection. Okay, it means I know that there is some kind of error. I also want to find out in which bit there is an error. So this bit is an error state, so we can correct that bit. Okay, so this is the basic fundamental of error detection and correction. And this error detection and correction, if we talk about OSI layer, then where does it occur? It occurs in transport layer and data link layer. So we are talking from the point of view of the data link layer, where we check bit by bit is there any error or not. Okay, so next point, if we talk about here, what are the types of error? Single bit error and burst error. In error, it is also true that it depends on the application. If application, let's say, sends some audio, if we talk about audio or video, then many times what happens, some content in audio, that video comes with error, means some changes occurred in content. Okay, then there was a little problem in the audio, but we bear it. Okay, we simply bear it in audio. But especially in text, if there is an application like WhatsApp, Facebook, where we are chatting or sending real time data on the basis of text, okay, then there we cannot bear this error. Okay, we can bear error in audio, but we can't bear error in text. Okay, but here if we talk about single bit error, single bit error means, as the name suggests, there is an error in one bit. Okay, like this example that I gave here, if sender sends data 101 and receivers receives 100, means there is a change in any one bit in the entire data block. Whatever packet we send, whatever block we send, in that block only one bit has changed. That is called a single bit error. Okay, and generally what is the reason of occurrence of error? When we transmit the data, we transmit to long distances. Okay, so when it travels to long distances, many times energy is lost, attenuation occurs. Because of these reason, many times there is a change in bit. Okay, and if we talk about digital data, the simple meaning of digital data is 1 becomes 0 or 0 becomes 1. In this, the meaning of data changes. Okay, so if the meaning changes, then the data is no use of receiver. So what we are talking about is how will receiver know? That is error detection. Okay, and if it can also correct, that is called correction, error correction. In single bit means one bit is changing. Okay, now let's talk about burst error. Burst error is what? Where more than one bits are changing. Okay, let's say if I send data 10110011 and receiver receives 10100111, this is the type of data receiver is receiving. Here burst error means more than one bits are changing, like this bit has changed here, and other than this, the next one we have this bit is also changed. But here if you ask, although it is a simple point, but if you are asked what is the length of error, then how do we find the length of error? If the bits in between are not changed, they are as it is, even then we will count it. Okay, fourth and sixth bit changed, length of error is 3 bits. Okay, now burst error is more common compared to the single bit error. Okay, then we have the detection method. If we talk about detection method, then which are the detection methods? Single parity, in which we talk about even or odd parity. There is a two-dimensional parity check. There is a checksum and CRC, which is the cyclic redundancy check. So these methods in this are very important methods. All these methods have their own advantages, their own limitations also, which we will discuss in this video also. Okay, and for error correction, we use Hamming codes. So all these methods are based on which technology? The base is redundancy. Redundancy means if I send, let's say there are 8 bits of data. If I send all 8 bits of data, then there is no way to check whether error has occurred or not. I always have to send extra bits. Extra bit means that if I have a block of 8 bits, then I cannot send data of 8 bits. I will send 6 or 5 or 7. Remaining bits be what? Redundant bits. Okay, or you can call it extra bit. Okay, which are used for what? For error detection or correction. So this is the introduction of error detection and correction. Now the first is single parity bit. We use the single parity bit method for error detection, and although this is a simple method and we call it least expensive method, means if we consider very high cost in the sense it is not for money, cost in the sense if we want to send more data, we want to send less redundant bits, means some application which says that we can bear a little bit error, then what is the least expensive method? That is single parity. Okay, why single parity is least expensive? In single parity, here we use m plus 1 formula. M plus 1 means m is the number of bits, or you can say m is the number of message bits, means the message you are sending has how many bits? M, and in that you have added only one bit. If we talk about double parity or CRC or checksum, in that we send more number of bits with the message. Okay, we send more number of redundant bits, so we are sending less extra bits here, therefore it is not very costly. Okay, it is least expensive and it is a very simple method. Here we can use even parity or odd parity, so this is a single bit, and in single bit even parity is mostly used. Okay, even parity means that the number of ones should be even, means in your data word the number of ones should be even. Okay, although you can use odd parity also. Odd parity means the number of ones should be odd. Okay, let's say if I send data 1010, so if we have data 1010, then you count number of ones. How many ones? 2. Then here in even parity, which bit we will add? 0. Reason? Because already here number of 1 is even, so the redundant bit, the extra bit that you are sending, this one extra bit you are sending, its value will be 0. Okay, if you are sending data, let's say 1110, this data if you are sending, then count the number of ones. 1 2 3, there are 3 ones, so the extra bit you want to send will be 1. Why? Because in the entire code word this is your data, and when you add 1 it becomes a valid code word. Then in this code word number of ones are how many? 4. This is called a even parity. Now here it can detect all the single bit errors in the code word, means if I am sending this data, let's say 11101 data. Okay, if I am sending, then in this data on the way, due to any noise, due to any natural effect like lightning or thunderbolt, then because of that if any one bit changes, let's say if I change the first bit, then what will this become? 01101. So receiver will see, okay, number of ones should be in this code word. How many number of ones are there in the data? 2. So if number of ones in the data are 2, then parity should be what? 0. But how much is the parity? 1. So from this it will understand that some change has occurred in the data, so from this it can detect that there is some kind of error. But at which location changes has occurred, that it will not know, means it can detect but it cannot correct. Okay, along with this, if we change in double bit, let's say 1101, let's say if I send this data and it reaches the receiver as 00101, means first 2 bits we changed. Okay, you can change any 2 bits, let's say first 2 bits if we change, then what is received? 00101, means the last one is parity, so it first checked in the data 0010. How many ones are there? There is single one, so means what should be in the parity? 1. And look what is in the parity, there is 1. Why? Because what is the total number of ones? 2, means this is an even parity. If it is an even parity, then receiver will feel that sender has sent this data, but sender had sent what? 11101. So here detection cannot happen, so means what can it detect? Single bit. Along with this it can detect all the errors. If number of bits changing are odd, means if 1 bit changing or 3 or 5 or 7, if these types of number bits are changing, then it can detect all the errors. Moving forward to Hamming distance. Hamming distance means if you are given this data word, let's say these are 4-bit data words from 000 to 111. I have all these strings, all possibilities I wrote here. Okay, and here in color I also counted their parity. Let's say 0001, how many ones? 1, so I put another 1. Okay, it becomes even. So here if you see in all code word, this becomes valid code word. If you carefully see this whole code word, parity is already attached to it. Okay, so Here, if we talk about Hamming distance, what is Hamming distance actually? You have to perform XOR operation on any two code words. Let's say 00000 and 11111. Take any two values. When you perform XOR on them, XOR means 0 in same values and 1 in different values. Okay, so 1 will be in different values, so there 4 values come here. So what is its Hamming distance? 4. Let's say if I take 01010 and we have data 1001. If I have to calculate Hamming distance of these two code words, what will it be? XOR applied 11011. So how much is Hamming distance? Count the number of ones. How many ones are there? 3. So Hamming distance here is 3. So if you check Hamming distance for this entire code word, in all these strings, some will have 2, some will have 3, but minimum Hamming distance will be how much? It will be 2. See this, 00000 and here is 11110. So what is the Hamming distance between these? Between these it's 4. Let's say if you count between these two, it is 2. If you check all these, then you will find out that minimum Hamming distance is 2. So fundamentals of Hamming distance, here is minimum Hamming distance is d. Then it can detect d minus 1 bits. It can detect error in d minus 1 bits. Means in this, if in this case you are asked that we send this data word, this code word, can it detect errors d minus 1 bits? See this. What does d minus 1 here? 1, because what is the value of d? Minimum Hamming distance is 2. So d minus 1 is 1. So why it can't detect 2-bit error? Reason it, see, if I take 000, meaning of d is you can change any 2 bits. If I change any 2 bits, let's say I change first 2 bits, then what will it become? 11000. And look, 11000 is already present in this data, in these 16 code words. So receiver will not know in this case that 11000 is a valid code word. So if you change any 2 bits, then that value will be among all these valid codes. So from this, receiver will know that whether an error has occurred or not. Will not know. Okay, many times this types of question also asked that if I have these code words, then calculate minimum Hamming distance, or how many bits error it can detect. So remember a simple fundamental: calculate minimum Hamming distance, whatever value you get, let's say d, then it can detect d minus 1 error. Now the most important topic, cyclic redundancy check. The topic is CRC. This method we use for error detection, and it is a very powerful method. Why we say powerful? And along with powerful, if I say this is the most widely used method, which is even used in real life environment, means in real life applications CRC is used the most to check errors. Okay, so here we are saying powerful on the basis of all odd number of errors and single bit errors and even double bit errors it can detect. Okay, and along with that, burst error of the length equal of polynomial degree. Okay, polynomial degree means the polynomial we use here, maximum degree of that polynomial. Like this is a polynomial, so the maximum polynomial degree is what? 4. So this burst length of burst error is 4. It can detect error equal to that. So on an average, if we say, it is a very powerful method. Okay, let's see how we have to use this method. So here we have dividend. Many times in the question you may be given this dividend directly in the binary form, or this dividend may be given to you in polynomial form. So let's see how to solve. Here we have been given an extra polynomial. In this polynomial, it is said in a way that this is a divisor, means with which we have to divide this value and find out what? We have to find out CRC bits. CRC bits are what actually? They are redundant bits. Okay, that's why we use kind of formula m plus r. M is number of bits in the message and r is the number of redundant bits. Okay, so first of all, if we say how many number of redundant bits will be there, according to this question, how you have to find it? What is the maximum power of polynomial? That number of bits you have to append. Okay, that number of bits you have to append means you have to append 4 number of 0. Okay, you have to append 4 zeros here, because the highest degree is what? 4. So here I will append 4 bits. Okay, 4 zeros, because these 4 bits we will replace from the remainder, and this will become a full string which I will send to the receiver. Okay, here if we say divisor, how do we do it? We have to divide this divisor value we have in the polynomial. Okay, so it will have to be converted. How to convert? Very simple method. Get the coefficient, like the coefficient of x in the power of 4 is 1. The coefficient of the x raised to 3 is 1. X to the power 2 is not there. Okay, means by default its coefficient is 0. So if you calculate 0 multiplied by x to the power 2, then it will be 0. Then 0 dot x to the power 1, because that is also not there. Okay, and lastly we have 1, x to the power 0 dot 1. Okay, so here if you get coefficient, it becomes 1 1 0 0 1. So this becomes your divisor. Next is one more important point. Here how many bits did we append? How many zeros? 4 zeros. Why? Because maximum value of polynomial degree is what? 4. But in case if you are given divisor directly this way, means it is given directly in binary form, then it has 5 values, 1 2 3 4 5. So don't append 5 values. In that case, from the number of bits in the divisor you have to subtract 1. Now next portion is very simple, binary division. You have to perform here, and in binary division we will use here XOR operation. Okay, so here 1 1 0 0 1, we don't have to find quotient here. Here remainder value is used, so remainder is to be calculated, and when you divide this, always you have to start from 1, means on the first position there should always be 1. Now so if you apply XOR operation here, what is XOR? 0 in same values, 1 in different values. Okay, 0 in same values means 1 1 becomes 0, 0 1 becomes 1, 0 1 becomes 1, 0 0 becomes 0, 1 1 becomes 0. 0 in same values and 1 in different values. So here we got 1 1 0 0. So always leading one, meaning start from here. If I have to start from here, then I have only 4 bits left, and in divisor I have 5. So we will simply carry 1 from above, 1 2 3 4 5. So here I will carry 0. Next again I have to start from leading one, where first value should be 1. So 1 1 0 0 1. Simply you have to perform binary XOR here. So same value means 0 0 0 0 1. It will be very simple. If you perform 1 at one time, it will give the right answer. If you do it one at a time, but it will be very lengthy, we don't have that much time. Okay, now what comes here? 1, you have to start from leading one, but there is nothing after 1, and here we have 5 values, so we will have to carry 4 values from above, 1 0 1 0. So here I have 5 values. Now we will take here 1 1 0 0 1. Okay, again we start with 1, and again XOR operation 0 0 0 1. Next again I have to start from leading one. First value should be 1, so we will again carry values from above. We take 0, take this 0 and one more 0, this will be 5 values. Okay, again we do it 1 1 0 0 1. So again we used 1 1 0 0 1. So 0 0 0 0 1, next 0. So if we start from leading one, then it will be 1 0, then we don't have any extra bits, so division is finished. Now what you have to do is append the remainder, okay, value in the 4 locations. But how? You can see 1 2 3 4 5 6 values. You can't append 6 values here. So remember a simple fundamentals, pick the last 4 values. Okay, what are the 4 bits in LSB? 0 0 1 0. So you replace this by 0 0 1 0. Okay, that valid code will become 0 0 1 0. So in this, how many bits of M is there? 10. And how many R bits? 4. So total 14 bits. Okay, you have to send. When we send these 14 bits, if they reach as it is to receiver, then in this case receiver will use the same fundamental. Receiver will divide this whole with the same divisor. After solving this, entire remainder becomes 0. This means that no error has occurred on the way. All the bits are as it is. Okay, this is simple fundamentals of CRC. So that's it for this video. We will meet in next video. Until then, bye bye. And CRC is very important method. Thank you.